This is lesson 3.1, so we're factoring trinomials of the form ax squared plus bx plus c here today. This is a continuation of factoring you did in Math 10, where you did, I'll just write this here, so Math 10, you did x squared plus bx plus c, and we'll see some examples of that in a second in our warm-up, but we're adding a layer of difficulty today. We're adding a number in front of the x squared and seeing how that changes our factoring. Okay, let's do a couple of examples from Math 10 just to remind ourselves of how we do this. So I'm going to do these two here. So I'm just going to rewrite them in the space below. So I'm going to do x squared plus 7x plus 10. So just a little reminder, the coefficients in your trinomial, so this is called a trinomial because it has three terms, so tri meaning three. These coefficients have names. This one where there's no coefficient here, that's just a 1, we call that a. The number in front of the x, we call it b, and the number by itself, we call it c. So what we do when you try to factor a trinomial with 1 as a leading coefficient is we solve a little puzzle, and I like to draw an X for my puzzle just to organize my work. And so I write the number c here, that's going to be 10 for us. And I write the number b down here, that's going to be 7. And what I'm trying to do is solve a little puzzle. I'm trying to think of two numbers that have a product or that multiply to 10 and they add to 7. So you can just guess and check numbers until you get the right ones. Start with the multiplying to 10 piece. There's only certain numbers that multiply to 10, like 1 times 10, 2 times 5, and you'll quickly find that the two numbers are 2 and 5. So those are our two numbers, and this is how we write our factored form. We just write it's equal to x plus 2, x plus 5. And if we FOIL this out, we'll see that it's equal to the original polynomial. X times x is x squared, x times 5 is 5x, and we have 2x here, and finally 10. So if we add those two like terms in the middle, we get our original polynomial back. So we verified that this is correct. Okay, let's do it one more time, and if you feel comfortable doing this and you don't need to see another example in the warm-up, you can go ahead and skip ahead to the past this warm-up if you'd like to, but I'll do one more example. So our a here again is 1, our leading coefficient is 1, our b is -2, and our c is -8. So I like to write this in a little x just to organize my work. C is equal to -8, b is equal to -2. So I'm looking for two numbers that add to -2 and that multiply to -8. So if you guess and check a bunch of things, you'll find eventually that the numbers are -4 and +2. Those add to -2, but they multiply to -8. So once we find our numbers, we can just put them into the factored form, x minus 4, x plus 2. And again, you could expand that out to verify and check, but I'm not going to do that here. But that's how that puzzle works. So now we're going to try some examples where the leading coefficient, that pink number I've highlighted here, is not 1. It changes the puzzle that you solve slightly, but we're still going to be looking for two numbers like we have here, and I'm actually going to set up the equations in the same way too. Okay, so let's scroll ahead here to the next page and look at example 1. So we're going to scroll past here, and we're going to do example 1a together. Okay, so let's look at 1a. The question says determine if each trinomial is factorable or not. I'm actually going to factor it as well, so I'm going to add to it here plus factor it, if possible. Okay, so I'm going to use a method called, there's actually like 3 or 4 different methods for factoring trinomials like this, but I'm going to use the method called the magic X method. If you have a different method that you prefer to use instead, some people use decomposition or grouping, some people use guess and check, whatever, slide and divide, whatever method you like, you can totally use, but I'm going to do the magic X method here. Okay, so I'm going to start with my polynomial, 6x squared plus x minus 12. And what I'm going to do here is just set up my X just like I did before so I can organize my work. I'm just going to scroll down a little bit so I have some space. And instead of solving the puzzle this time with just writing c, I'm going to write a times c. So a times c here, remember this is a, the leading coefficient in front of x squared. B here is 1, and c is negative 12. So 6 times negative 12 is negative 72, and b would be 1. So I'm looking for two numbers where the product, or they multiply to negative 72, but they add, or their sum is 1. So we can guess and check a bunch of numbers. If their product is negative, though, I know one of the numbers has to be negative. So the numbers are 9 and negative 8. Okay, here's where this method changes a little bit. What you have to do now is divide both of those by the leading coefficient. And you didn't have to do this before because the leading coefficient was 1, so dividing by 1 wouldn't change anything, but here we're going to divide by 6. Okay, and then we're going to reduce those fractions, and what the fractions we end up with, those are going to be the numbers we put into our factored form at the end. So we're going to reduce both of these, if possible. Sometimes you can't reduce them. In that case, you just leave it, but here we can reduce both. Okay, so on the left here, we can divide by 3, so we get 3 over 2. And on the right here, we can divide by 2, so we get negative 4 over 3. Okay, now we're ready to actually write our factored form, and I'll show you how it works. So the two numbers that we end up with in the numerator, those are going to be our constant terms in our factor. So we have positive 3, so we write plus 3, and we have negative 4, so we write minus 4. Okay, and then we have the numbers in the denominator. Before, those were just 1. In the more simple example here, they're actual numbers that are not 1. Those are going to be the coefficients that go in front of the x. So here we have 2x, and then here we'll have 3x. And there we go, we have our factored form. And you could expand to check that, but that is the correct answer. That is the correct factoring. Okay, let's just try this 2 more times. If you want, you can pause the video here and try some on your own, but you can also do them with me. Okay, let's scroll ahead again. And we're going to try this one here. Again, if you want to try this on your own, you can, or you can do it with me. By the way, if the question says determine if it's factorable, essentially you just set up this puzzle and you just see if you can solve it or not. So if the puzzle can be solved and you find the two numbers, then the question is factorable. And sometimes polynomials aren't factorable. You can't find the two numbers. And then in that case, you would say, no, you cannot factor this question. Okay. So here our product that we are looking for is negative 15, and our sum that we are looking for is 14. So the two numbers that satisfy this puzzle are positive 15 and negative 1, because if you multiply those, they equal negative 15. If you add them, they equal 14. Okay, next is we divide by the leading coefficient, which in this case is 5. So I'm going to divide by 5, and I'm going to reduce if possible. Reduce. I'm writing a lot more out than I would normally do in a question like this. You don't have to write those words that are in pink there. If you're kind of a minimalist, you can just write what I'm writing in blue and black. Okay, so here we can reduce this to 3 over 1. And here this cannot be reduced, so I'll just rewrite it again here. Okay, so the numbers in the numerators, the top numbers, are going to be the constant terms in my factor. And the reason this works is those two numbers, 3 and negative 1, multiply to this number here, right? The constant term in our trinomial. So positive 3 and negative 1. And then the two numbers on the bottom, the denominators, those are going to be my coefficients in front of x. When the coefficient is 1, we actually don't need to write it, so I'll just write x, and then over here I'll write 5x. Okay, there we go. There's our factored form. Okay, we're going to do this one more time. Again, feel free to pause and do the question on your own, and then come back to check the answer if you would like to. Okay, we're going to do this one, and that's going to be the end of the lesson. Okay, so again, I'm going to use this magic X method, and if I didn't already mention it, you can actually use any method you want. This is just my preferred method. But yeah, if you have another method you prefer better, go ahead and use it. Okay, so here my a and my c, remember a is this first coefficient, c is the constant term, and b is the coefficient in front of the x. So a times c here, 4 times 15 is 60, and the b is 16. So the two numbers that solve this puzzle are 10 and 6. And then we divide by that leading coefficient, which happens to be 4 in this example. And then we reduce. So I'm writing less down here because we've already done a few questions. On the left side, we can divide by 2. And on the right side, we can divide by 2 as well. And those look fully reduced to me. So the two numerators are going to be our constant terms in our factor. So 5 and 3. I'll color them yellow just to be consistent here. And then the two denominators are going to be my coefficients in front of x. Just a reminder too, I want to stress that like on a quiz or a test, you should be verifying this if you have time, multiplying it out. I will do it here just to kind of show you. So 2x times 2x would be 4x squared plus 6x plus 10x plus 15. And we see the middle term does equal 16x. So we do have our trinomial back. So I really encourage you to check your answers because it is easy to make a small mental math error when you're doing these factoring questions. Okay, that's the end of the lesson.